In this video, we're going to learn how to add and subtract numbers written in standard form. And so before we do, we're going to make sure we remember how to convert from standard form to an ordinary number. So take, for instance, 5.6 times 10 to the fourth power. We can work this out by recalling that 10 to the power of 4, or 10 to the fourth power, is 10 times 10 times 10 times 10. That's the same as 10,000, so we need to work out 5.6 times 10,000. Well, since we're multiplying by 10,000, we're going to move the digits in the number 5.6 to the left 4 places. And that gives us 56,000. So 5.6 times 10 to the power of 4 is 56,000. But what about 1.23 times 10 to the power of negative 3? Well, we might remember that 10 to the power of negative 3 is 1 over 10 cubed, or 1 over 1,000. And so this is the same as 1.23 times 1 over 1,000, which is in turn the same as 1.23 divided by 1,000. And when we divide by 1,000, we move the digits to the right 3 places. And so 1.23 divided by 1,000 is 0.00123. Notice that with 10 to the power of 4, we move the digits to the left 4 spaces, and with 10 to the power of negative 3, we move the digits to the right 3 spaces. That power, or index, essentially tells us how many spaces we're going to move each of our numbers. And this is really useful because we can use this skill to help us to add or subtract numbers in standard form. Let's have a look at an example. Let's begin by working out 5.6 times 10 to the power of 6 plus 8 times 10 cubed. We'll begin by converting each number, which is written in standard form, into an ordinary number, and that should make the addition part fairly easy. We begin with 5.6 times 10 to the power of 6. This is telling us to multiply 5.6 by 10 6 times. In other words, to move the digits in the number 5.6 to the left 6 times. And so when we do, we see that 5.6 times 10 to the power of 6 is the same as 5,600,000. Let's repeat this process with the number 8 times 10 cubed. This time we're going to multiply 8 by 10 3 times, essentially moving the digits to the left 3 spaces. And that gives us 8,000. Finally, we can use the column addition method to find their sum. 0 plus 0 is 0. We have a 0 here and a 0 here. 0 plus 8 is 8. 0 plus 0 is 0. 6 plus 0 is 6. And then we have a 5 in the furthest left column. And so 5.6 times 10 to the power of 6 plus 8 times 10 cubed is the same as 5,608,000, which can be written in standard form as 5.608 times 10 to the power of 6. Now notice how the power in our solution matched the highest power of 10 in our question. And that leads us onto a slightly different method. We're going to take the number here which has the lower power of 10, so that's 8 times 10 cubed. And we're going to rewrite it so it's something times 10 to the power of 6. Now, because we've essentially multiplied 10 cubed by 10 another 3 times, then we need to divide 8 by 10 3 times to match this. 8 divided by 10 cubed, or divided by 10 3 times, is 0.008. So 8 times 10 cubed is the same as 0.008 times 10 to the 6th power. And now that the powers of 10 are the same, we can simply add the number in front of them. We're going to add 0.008 to 5.6. That's 5.608, and so once again we've shown that the solution here is 5.608 times 10 to the power of 6. Now either of these methods is perfectly valid. It's very much down to personal preference. Let's see what these methods look like when we're subtracting numbers in standard form. Let's take 8.11 times 10 to the power of 6 minus 1.2 times 10 to the power of 4. Once again, we could simply begin by converting each number into ordinary form. Take 8.11 times 10 to the power of 6, for instance. We're going to move all of the digits in the number 8.11 to the left 6 spaces, and that gives us 8,110,000. Then we take all the digits in the number 1.2 and we move them to the left 4 spaces, giving us 12,000. We can now use the column method to perform this subtraction. 0 minus 0 is 0. We want to work out 0 minus 2, so we'll have to borrow from this column, making this a 10. And then we do 10 take away 2, which is 8. We now want to work out 0 minus 1, which we can't do using the column method, so we borrow again. And 10 take away 1 is 9. 0 take away 0 again is 0, and 8 take away 0 is 8. And so we get the number 8,098,000, which we could write in standard form as 8.098 times 10 to the power of 6. Now, in fact, when we looked at the previous example, we saw that there was another way to perform the calculation. And this involves writing 1.2 times 10 to the power of 4 as something times 10 to the power of 6. Essentially, you want the powers to match. Now, we will look at this method here, but in fact, it's not much quicker than the method we just saw. Because we've multiplied 10 to the power of 4 by 10 squared, we need to divide 1.2 by 10 squared to make sure the size of our number doesn't change. And so 1.2 times 10 to the power of 4 is the same as 0.012 times 10 to the power of 6. Now that their powers are the same, we can subtract 0.012 from 811, which we can write as 8110. And then we borrow as we did before. 10 take away 2 is 8. We borrow again. 10 take away 1 is 9. 0 take away 0 is 0. And then we pop the decimal point here. 8 take away 0 is 8. And so once again we get a solution of 8.098 times 10 to the power of 6. Now, if you do choose to use the second method, you need to be really careful when subtracting these decimal numbers.